we have the National 5 Maths 2014 paper 1. First question, non-calculator paper. First question, 5/12 multiplied by 2 and 2/9. Give the answer in its simplest form. So simplest form, there may be a bit of cancelling down at the end. So to multiply fractions, we need to make the fractions top heavy if they are not top heavy already. So 2 wholes and 2/9. Well, 9/9 make 1 whole. So 2 wholes would be 18/9 plus another 2/9 would be 20/9. So then we have 5/12 multiplied by 20/9. We could do 5 times 20 is 100, 12 times 9 is 108, then cancel. But a much more sensible and quicker and more efficient way is to cancel anything on the top with anything on the bottom. So here we have 20/12. Well, we can divide 20 and 12 by 4. So that would become 5 and 3. So 5/12 times 20/9 is the same as 5/3 times 5/9. Then we are just multiplying the top by the top, 5 times 5 over 3 times 9, and that will become 25/27. I do not have the mark scheme at the moment. I'm doing this just a couple of days after the actual exam. I'm assuming that the marks will be given here and here. So knowing to multiply and getting the final answer. Question number 2. Quite a nice question. Multiply out the brackets and collect like terms. So I would go for the FOIL method that quite a lot of you will be familiar with. So the FOIL first term, the F from FOIL is the first terms in each bracket. 2 times 3 is 6, x times x is x squared. Then the outside terms in each bracket, 2x times 1 is positive 2x. Negative 5 times 3x, negative 15x. Negative 5 multiplied by 1, negative 5. Then tidy up the x terms. Positive 2 subtract 15 is negative 13x. So 1 mark for multiplying out, 1 mark for tidying up. Question number 3. Express x squared minus 14x plus 44 in the form x minus a all squared plus b, or completed square form. Several different ways of teaching this. I'll just go through it the way that I teach my classes. The reason why I teach it this way, I think it's just the easiest way to understand. So x squared minus 14x, I just look at these two terms. Actually, I just look at the minus 14x and I just half the coefficient or the amount of x's I have here. So half of minus 14 is minus 7. I bracket that and I'm going to square it, which means multiply it by itself. So following the FOIL method from above, then tidying up, I get x squared minus 14x plus 49. So if you half the coefficient of x here, and then square the whole bracket, this number always doubles. So we've got minus 7 here, comes out as minus 14. So working backwards, half the minus 14 to get the minus 7 in the bracket. So then after I multiplied out, I'm going to compare it to what I've got here. So x minus 7 all squared would end up with a plus 49 at the end. But in the question we've got plus 44. So we've got 49, we need to get 44, so I just need to subtract 5 from here. So in the bracket I've got x minus 7 all squared, and to make it into the plus 44 I need to subtract 5 off the last bit, or it's just the same as subtracting 5 here. So x minus 7 all squared, subtract 5. So it's only 2 marks, so again I'm guessing about the mark scheme, but 1 mark for this bit, 1 mark for that bit. You'll be able to check on the SQA website for a mark scheme at a later date. Question number 4. 2u minus v, that just means 2 of these, subtract 1 of these. So 2 lots of negative 2, 3, 5, subtract 0, negative 4, 7. So 2 minus 2 is minus 4, 2 3s are 6, 2 5s are 10, subtract 0, subtract minus 4, which becomes plus 4, subtract 7. So minus 4 subtract 0, 6 add 4, 10 subtract 7. There we go. Number 5, we have a triangle question. It's telling us sin k and sin l, so it's probably a sine rule question, which we normally get on paper 2. But it's telling us that what the sin of k is. That means if you typed into the calculator the sin of the angle, the calculator would tell you 0.4. So we are definitely not trying to work out the sin of 0.4. It's telling us that the sin of the angle would be 0.4. And the sin of angle L would be 0.9. So just applying the sin rule, which is A over sin A equals B over sin B equals C over sin C. We have 18 over sin of the opposite angle here, sin L. It's Lm, which we are asked to find out, over the sin of the opposite angle, which is K. So Lm over sin K. Substituting the values that we know. We know sin L is 0.9, sin K is 0.4, tells us up there. And cross multiply the 0.4 to get Lm on its own. So 18 times 0.4 over 0.9. So I know what 18 fours are. I can multiply by 4. Could double it and double it again, or at the side we could just scribble down 18 times 4. But anyway, that comes to 72, so 18 times 0.4 would be 7.2 divided by 0.9. A couple of ways of doing this, and just say, well, how many 0.9s makes 7.2? That's just like asking how many 9s make 72, which should be 8. Or we can multiply top and bottom by 10 here to get 72 over 9, which again would be 8. So we've basically got a sine rule question with a little bit of multiplying by decimals there. Number 6, we have a straight line graph. The line of best fit has been drawn. We're given point A and point B, given the x and y values, or in this case the c and f values. So we don't actually have a question yet, so scroll down to the next page. Find the equation of the line of best fit in terms of f and c. So here's our line of best fit. We're asked to find the equation of the line. To do that, we need two things. We need the gradient and we need the point on the line. So to find the gradient, it is y2 minus y1 over x2 minus x1. Remember here, y is c. I've just renamed the axes because it's calories in the context of the question. So I've got x1, y1, x2, y2. So substitute those values in. 500 subtract 200 over 25 subtract 5. It's 300 over 20. And 15 20s make 300, so that'll be 15. So the gradient is 15. Then substitute in 1 point. Well, we've got a choice here. We can either use the 5 and the 200 or the 25 and the 500. Either one would be fine. I've just picked the ones with the smaller values. Make life a little bit easier for myself. So y subtract 200 equals 15 bracket x minus 5 when we're substituting into y minus b equals mx minus a. Multiply out this bracket, add 200 to both sides, or move the negative 200 over and make it positive, if that's how you've been told how to do it. Get y equals 15x plus 125. Of course, it says in terms of f and c. So the y-axis is renamed c, the x-axis is renamed f. Part B, a super deluxe sandwich contains 40 grams of fat, so the value of f is 40. Use your answer to part A. Use this. So I'm just going to substitute the 40 for f. So 1540s plus 125, so that'll be 600. Again, if you can't do 1540s, do a sum over here at the side. You don't need to do it in your head. Non-calculator means you don't need to do it in your head. You can write down the sum. 600 plus 125, 725 calories. This question very similar to one in the unit tests. So hopefully it'll be straightforward. So we've got y equals ax squared, find the value of a. So the y coordinate and the x coordinate are linked together by this rule. The y coordinate is always a times the x coordinate squared. So I've got an x coordinate, I've got a y coordinate on the graph. I just substitute those values in. So y is 45 when x is -3. -3 squared is 9. 45 equals 9a, or a times 9, which is 9a. And 9 fives are 45, so the value of a is 5. Question number 8. The third question. Again, in its simplest form, so there will be some simplifying to do. So here, this root 10 here is a kind of a big clue. It's telling us these other two numbers will more than likely be able to be written in terms of the square root of 10. And also, we're always looking for a square number that can go into the 40 and into the 90. We should also check the 10 as well. So a square number that goes into 40 is 4. So root 40, or the square root of 40, is the square root of 4 multiplied by the square root of 10. There isn't a square number that goes into 10, so I'll just leave that as 4 root 10. And here I will have root 9 root 10. And again, 9 is a square number. I could have broken this down into 20 times 2 or 8 times 5. But the reason why we do this, we know the square root of 4 is 2. So root 4 root 10 becomes 2 root 10. That's still 4 root 10. Root 9 root 10, square root of 9 is 3, becomes 3 root 10. So here we've got 2 root 10s, add 4 root 10s, add 3 root 10s. That is basically 2 somethings, add 4 somethings, add 3 somethings. Would be 9 somethings, or in this case, 9 root 10. Question number 9. 480,000 tickets were sold for a tennis tournament last year. This represents 80% of all the available tickets. Calculate the total number of tickets that were available for this tournament. So 80% of the total amount was 480,000. So I've just written that down. What I want is the original amount, which would have been 100%. So to get from 80, so there's a couple different ways of doing this. As it's a non-calculator paper, to me this is the most, or the easiest way to do it, the most logical way to do it, the most intuitive way to do it. So I'll just say, right, I can't go from 80 to 100. Well, I could multiply by 1.25, but I don't really want to multiply this number by 1.25. So I'm going to say, right, I'm going to go to 10%. I could also have went to 20%, but I'm going to go to 10%. So to get from 80% to 10%, I need to divide by 8. So I need to divide this side by 8. So 10% of the ticket sales would be 60,000. So now that I'm at 10%, I can multiply by 10 to get 100% of the ticket sales. Again, the reason why I want 100% is because that would be the original amount. And multiply the other side by 10 as well. So the amount of tickets available, 600,000. The graph of y equals a sin x plus b is shown below. Alright. A number here at the front stretches the sin graph by a factor of a. So the sin graph normally starts at 0, peaks at 90, comes back through at 180, bottoms out at 270 and at -1, and back up to 360. So normally, basically, in terms of the height, it goes up to 1 and down to -1 normally. This graph goes up to 3, down to -3. So it's 3 times as high. So it's been stretched by a factor of 3. So a will be 3. This x plus b, anything next to the x or in a bracket will be a horizontal shift. So normally it starts at 0, comes back down at 180, crossing the x-axis again, comes back up at 360. This has been moved along by 40. And if it's actually moving to the right by 40, that should be a negative sign in the bracket. So b will actually be -40. I'm not going to go into that too much why that is. because I'm just going over the paper. You go back, read your notes, talk to your teacher about it, because it can take a long time to explain. But if the whole graph's moving to the right, it should be minus 40. 11a, a straight line has equation 4x plus 3y equals 12. Find the gradient of this line. So if we can get it into the format y equals mx plus c, you can just have a look at the coefficient of x, or how many x's we've got, and that tells us the gradient. So first of all, get the 3y on its own, so subtract 4x from both sides. Divide everything by 3. So we end up with y equals negative 4/3 x plus 4. So the gradient would be negative 4/3. Part B, find the coordinates of the point where the line crosses the x-axis. Or let's say x-axis. If it was just asking for where it crosses the y-axis, it would just be this number, because it's in the format y equals mx plus c. But it's asking where it crosses the x-axis. Right, what do I know? I know that on the x-axis y equals 0. Because we're none on either up or down. If we're sitting on the x-axis, we're at height of 0. So substituting that back into this one, or we could substitute into this one. I'm going to choose to put it into this one because it's got whole numbers. So substituting y equals 0, I get 4x plus 3 zeros equals 12. Or in other words, 4x equals 12, in which case x would be 3. The question does ask for the coordinates. So the coordinates would be 3, 0. Again, I know it's 0 because y equals 0 on the x-axis. Question number 12 is the classic Pythagoras in a circle question. And again, if you've done a lot of revision, hopefully you'll be aware of that. Or if you're not aware of that, you need to do a lot of revision. So the radius of the circle is 15 centimeters. So from C to B would be 15, because the radius is from the middle to the edge. C to P would be 15. C to Q would also be 15. So quite often in these questions, we're given the radius, and we'll just have to understand that from the center to any point on the circumference will be 15. A is the midpoint of the chord PQ. So as this is the midpoint, that means it's going to be a line of symmetry down the middle. The length of AB is 27, so A to B is 27. So if AB is 27, then A to C would be 27, take away whatever BC is, which again is the radius, which is 15. So 27 subtract 15 is 12, so A to C is 12. And also if we want it, C to P is 15. And as we have a line of symmetry here, this will be a right angle, which is where the Pythagoras comes from. So we have the 12, which again, guys, is this part. We have 15, which is this part. And I'm going to try and find out AC. Sorry, AP, beg your pardon. Because if I can find out AP, then I'll just double it to get PQ. So Pythagoras says that one of the short sides squared plus the other short side squared equals the hypotenuse squared, or the long side squared. So AP squared plus 12 squared equals 15 squared. Now again, if you know what 15 squared is, just write it down. If you don't, over here, 15 multiplied by 15, work it out. And again, 12 squared, hopefully you know that's 144. Or do 12 tens, add 12 twos. Or write the sum over here and multiply it out. You don't have to do it in your head. So 225 minus 144, bringing the 12 squared across there, is 81. So AP squared is 81. So square root both sides, AP will be 9. Again, guys, we're not being asked for that in the question. We've got this bit, we're asked how long is PQ, which is twice the length because of the symmetry in the circle. So PQ will be 18. Question number 13. A question that quite a few of the pupils in my school found quite difficult. So I'll go for this one. So the diagram below shows the path of a small rocket which is fired into the air. The height h meters of the rocket after t seconds is given by this. After how many seconds will a rocket first be a height of 60 meters? The height h of the rocket after t seconds is given by this formula. So if we know the height 60, substitute 60 into there. And after that, collect everything over to the left-hand side to let it equal 0. I've moved the negative t squared across to here to make it positive, because I know when I'm going to solve something like this, it's going to be a double bracket question. So what multiply together makes 60, so I've got 6 and 10. And if I do FOIL, I'd get negative 10t, negative 6t. That does give me the negative 16t there. Then solving either this bracket 0 or this bracket 0, in which case t will be 6 or t will be 10. So I've got two answers. Going back to just double check the question. After how many seconds will a rocket first be at a height of 60 meters? Well, obviously 6 comes before 10. So a time of 6 should have an S after that. It's a little bit sloppy. Will the rocket reach a height of 70 meters? Justify your answer. Probably a couple different ways of doing this. This is the sort of mathematically correct way of doing it in terms of your sort of National 5 work. If I could find out the value of t here in the middle, I could just substitute into here to get the turning point, which would give me the maximum height. So can I find out these two values? Because then I could find the halfway point. Well, this one's obviously 0. At this point, h is 0. Height 0 because it leaves the ground at 0 seconds, travels up the way, comes back down to the ground here. So at these 2 points, the height is 0. So the formula 16t minus t squared would equal 0 at this point and at this point. So then if we factorize that, we get, take out a common factor of t bracket 16 minus t equals 0. So either the front bit 0, in which case t is 0, or the bracket 0, in which case t would be 16. So if that's 0 and that is 16, then the midpoint would be 8, time of 8. So if I just substitute 8 into here, that'll give me the maximum height. So h of 8, or the height at the time of 8 seconds, is 16 eighths subtract 8 squared. Well, that's like 16 eighths subtract 8 eighths. So that'll leave me with 8 eighths, which are 64. So it only goes to maximum height of 64 meters. Will the rocket reach a height of 70 meters? No, as h is less than or equal to 64 meters. Because at the maximum point there at 64, all other times would be less than 64. So it's never ever getting to a height of 70. And that is the end of the paper. If you'd like extra practice papers, have a look at wademaths.weebly.com. There are lots and lots of practice papers on there with written solutions and also the answers, but the written solutions are very, very helpful when revising.